unless
the
individuals were husband and wife.
So we received the samples that you sent up, and when we first examined them, they didn't look very good, very dry, very desiccated, very small and very fragmentary. And so for that reason, it was going to be very difficult for us to do the analysis. We then went on to start to process the samples and try to understand the quality of the DNA. Is it going to be viable for analysis? In this particular case, we found the DNA was fairly degraded, fairly damaged, and for that reason, it limits what type of work we can do.
The question now, is there enough DNA material to create a significant profile? To obtain the maximum amount of information, the biologists will try to recover what they call nuclear DNA from the bone cells.
The extraction analysis showed that nuclear DNA was very difficult to recover. We have then focused on the mitochondrial DNA. The mitochondrial DNA, being inherited from mother to child and maternally inherited, means that we can only identify those types of relationships.
The bone material is too degraded to recover DNA from the nucleus of the cells. And so the DNA extraction is now focused on the bone cells' mitochondria. Mitochondrial DNA can only tell us whether or not Jesus, son of Joseph, had the same mother as Mariamne, whether or not they were brother and sister. If the biologists cannot recover mitochondrial DNA from the bone cells, the test will have to be aborted, and we will never know the true relationship between Jesus and Mariamne.
We have indeed been able to achieve results. We got the mitochondrial DNA. It was very fragmented, very small amounts of DNA. We were able to amplify it, we were able to sequence it. We then went on to clone those sequenced DNA fragments, and by cloning the DNA, we're able to then compare many, many copies together, and that increases the validity of the work, and that way we're able to compare the sequences between that one individual and the other individual, and that's essentially what we've done, and I can show you the results here today. Okay, so what we have here is we have two sequences, just representative sequences, one from each individual, and what I'm going to show to you here is some of the variations between the two individuals. And so we have a polymorphism here, this G and the A. A polymorphism is a variation between this sequence and another sequence, or a variation between this sequence and the reference sequence. We use a polymorphism to indicate or identify a mitochondrial profile. And this polymorphism shows one difference between the two individuals. We also have another polymorphism here, where we have a T and a C, showing another polymorphism difference. So we have a number of polymorphisms that show differences between the two sequences. We can then conclude that these two individuals, they're not related, or at least not maternally related. They do not share the same mother. It can't be mother and child. It can't be brother and sister. So for these particular samples, because they've come from the same tomb, and we suspect it to be a familial tomb, these two individuals, if they were unrelated, would most likely be husband and wife.